Okay guys, welcome back to the review for test 2 for Mat-172. We are going to be doing several problems in a row in this video. They're all applications of some different half-angle, double-angle formulas. So with that, let's get started. 11a asks us to rewrite and then evaluate the following. The cosine of 4 pi over 7 times the cosine of 5 pi over 21 plus the sine of 4 pi over 7 times the sine of 5 pi over 21. So whenever I see cosine, cosine, sine, sine, that makes me think of a sum and difference formula. So let me find this. So we've got cosine, cosine plus sine. So if you look here, cosine, cosine plus sine, sine. So we're using this one. So this is the cosine of the first angle minus the second. So we can rewrite this as the cosine of 4 pi over 7 minus 5 pi over 21. Okay? So again, whenever you see cosine, cosine, and sine, sine, this is a difference problem. So now we need to evaluate this. 4 pi over 7 and 5 pi over 21. The common factor here is 21. So this is the same as the cosine of, multiply by that by 3, so 12 pi over 21 minus 5 pi over 21. All right, so that's equal to the cosine of 7 pi over 21. 7, 21. This is the cosine of pi over 3, which is 1/2. Okay, so that's 11a. Again, when you see cosine, cosine, sine, sine, that's a difference formula. 11b. So we've got the tangent of 51 degrees minus the tangent of 21 degrees over 1 plus tangent of 51 times the tangent of 21. All right, again, we look on our reference sheet. And if you've got tangent of 1 minus the tangent of the other one, it's a difference formula. So that's the tangent of the first minus the second. Okay, so this is equal to the tangent of 51 minus 21. All right, guys, again, this is just pattern recognition, understanding that this is the tangent of the difference. We're just going to evaluate this. So this is the tangent. 51 minus 21 is 30. And the tangent of 30 degrees is 1 over the square root of 3. Okay? So, guys, these were both difference formulas in problem number 11. So now moving on, we're going to talk about problem 12. Problem 12 says, use addition and subtraction formulas to rewrite this expression. We've got cosine of x plus y times the cosine of x minus y. So we're going to be expanding this out and expanding that out. So the cosine of x plus y is cosine x cosine y minus sine x sine y. So that's an expansion. And this is a multiplication times this guy, which is cosine x cosine y plus sine x sine y. This is a binomial. That's a binomial. So we're just going to FOIL it out, right? So first we've got cosine squared x cosine squared y. Outside we've got plus cos x cos y sine x sine y. Insides, we've got minus cos x cos y sine x sine y. And then lastly, we've got minus sine x squared sine squared y. Okay, first, outside, inside, last. This is a plus term, and this is minus the same term, so they go away. So we're left with cosine squared x cosine squared y minus sine squared x sine squared y. This has not been evaluated, it's just been rewritten. And that is number 12. All right, moving along, in problem 13, we're asked to use the double angle formulas to rewrite these expressions. We've got 2 tangent of 2 degrees over 1 minus tangent squared of 2 degrees. So if we look carefully, this is exactly the right-hand side of this identity. So this is equal to the tangent of twice this argument. So this is equal to the tangent of 2 times 2 degrees, which is the tangent of 4 degrees. All right, not so bad. That was part A. Part B asks, we've got 2 tangent of 2 theta divided by 1 minus tangent squared of 2 theta. By the same identity, this is tangent of twice the argument, which was 2 theta. So this is the tangent of 4 theta. All right, so that was problem 13. Moving on to problem 14. In problem 14, they say use the half angle formulas to rewrite these. So 14a says the square root of 1 minus cosine of 30 degrees over 2. So then I look at my reference sheet, and it is this one. So that's sine of alpha over 2. So this gives us the sine of whatever's on the inside, 30 degrees, over 2. And so that gives us the sine of 15 degrees. And we're done. So again, guys, it's all about using the formula sheet to your advantage. All right, and then in B, we've got the square root of 1 minus the cosine of 10 theta all over 2. Well, okay, this is the same identity, right? 1 minus cosine something. So that's equal to sine of that something, 10 theta, divided by 2. So this is just the sine of 5 theta. So this has been problems 11 through 14. I hope you find them helpful. And if nothing else, use the reference sheet. Okay, bye guys.